Hello, my name is Sairy and I am going to be working through the week 10 Teach Me video. I will be working through problem number 3. It tells us that graph f, which is a continuous and differentiable function everywhere except when x equals -2, has the following properties. So just judging by that statement alone, we can tell that x equal to -2 will likely be a vertical asymptote. And otherwise, it's just going to be continuous into negative infinity and positive infinity. So there will be a break here. We know that we can then just interpret our next statements that will help us identify the graph that we will be working with. Here it tells us that to the left of what we know to be our asymptote of x equal to -2, the graph will concave down. Our second statement, and that is for our second derivative, also for our second derivative of the graph, it will concave up to the right of the number of 4 of x equal to 4. So to the right of x equal to 4, the graph will concave up. And for our first derivative here, we know that for numbers less than -2 and numbers greater than 4, the graph will be decreasing on both intervals. And that's what we can keep in mind when we're graphing. The first derivative at x equals 3 is going to be 0. This means that this is a critical point, and it means that our slope here will be equal to 0 somewhere on the y-axis for x equal to 3. And then for our limits here, as the limit of f of x approaches positive infinity, it is equal to 5. That means that we have a horizontal asymptote here. So y equals 5. And then as the limit of x approaches negative infinity, f of x is equal, did I read that correctly? As the limit of f of x approaches negative infinity, it is equal to 1. So we have another horizontal asymptote, y equal to 1. And as the limit of f of x approaches -2, it is equal to negative infinity. And we actually have a vertical asymptote here. Vertical asymptote. And that is going to be x equal to -2. Yeah, so that just tells us that our graph is going to be likely dropping down near our x equal to -2. It will be dropping down to -infinity. And from this information, I believe that we can start drawing our graph here. So, let's see. Just gonna draw a graph like this. Like this. And we can give ourselves enough space here. I'm gonna do 5, and I'm gonna do 10. I'm gonna do 5 again, and another 10. And same here. 5, 10, and 5, and 10. Okay, and we can do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3. Oops. 2, 3, 4. Okay. I believe that should be enough for us to graph this correctly. We can start by graphing our vertical asymptote, x equal to -2. So it's gonna go here. I'm gonna move this over a little bit because I'm not really happy with the placement there. Oops. I'm gonna do it here. It's just, oops. Let's see. Okay. Here, and then yeah, I get a little overwhelmed when I'm drawing it out for the Teach Me videos, but that should be a vertical asymptote, x equal to -2, and then we have a horizontal asymptote at y equals 5, so here. And then at y equals 1, which would be here. So those are our horizontal asymptotes. So y equal, do it on the other side, equal to 5 and y equal to 1. And then from here we can sort of begin figuring out our graph. We know that to the left of the asymptote x equal to -2, it will concave down. So that is going to look, let's see, like this. I believe something like this. It won't touch our asymptote on either y equals 1 or x equals -2. So not touching our asymptotes, but just concaving down. And then we will have another line. It will be we can label our critical point here. So if our critical point is here, I'm just going to draw an X here so that we know that that is where our slope will be equal to 0, which basically just means that it will look like this. So we can do something like, and it will be decreasing and concaving up to the right of x equal to 4, and then we will have a slope of 0, and we know that the rest is decreasing, so something like that, but we can draw that on our graph here. Something like this. Like this. See. We can draw the point, I guess. If this is our zero, it will go like this. Okay, and then like this, so approaching the asymptote but not over it, and then like this. Trying to get that correctly, something like this, I believe. So something like this is what it will look like. And that should be our graph based on what we know. I hope that was correct, but thank you for watching.